Okay, I see students are still entering the class. Okay, I think we shall begin our class. Okay, we are going to continue from last class. Okay, let me turn off my video so that I have better internet connection. Oh yes, okay, stop video. Okay, remember, okay, basically we have covered all parameters. Okay, so as a summary of this chapter, two-port network, we have basically three main types of parameters, whereby these main parameters are actually four lah, not three, four. Well, in fact, it's three actually, because the first parameter, the impedance parameter, is paired with the admittance. But because the Z parameters, the impedance parameter, is the fundamental, because from Ohm's theory, Ohm's law, we have V equals to IR, R being the R is the resistance, but in terms of impedance, we have V equals to IZ. So resistance and impedance are the main components in an Ohm's law, and admittance is actually the inverse of the impedance. So that's why it is sort of separate, but actually admittance and impedance, they complement each other. So that is one set of parameters. And then the second set is hybrid parameters, where we have hybrid parameters. The inverse of it is the G parameters, inverse hybrid. And the third section of the parameters is the transmission or the ABCD parameters. And the inverse of it is the T parameters. So if you see small t, it indicates the inverse transmission. If you see transmission parameter, it refers to the ABCD parameters. So don't get confused lah. Sometimes you will see questions, especially the problem solving questions from the textbook. Sometimes you are asked to calculate for the t, small t parameters. So the small t means inverse lah. Okay, and for each of these parameters, you have to be clear. For example, for the impedance parameter, we are evaluating the voltage equations, where we have, for the impedance parameter, we have equations of V1 and equations of V2 as a representations of the current equation. Voltage as a representation of the impedance parameter multiplied by the I1 and I2, where I1 and I2 refers to the input and output current. Whereas in Y parameters, we evaluate the current equations, because in admittance parameter, we have I1 as a function of the Y parameter multiplied by the voltage equation, where we have the voltage equation as V1 and V2 lah, voltage input and voltage output. So in other words, instead of another key word for these two parameters, the Z parameters is actually a short circuit test. So sorry, you want to make voltage equals to 0. Yeah, you short circuit. Whereas Y parameters, you want to make the current in impedance parameter, you want to make the current equal to 0. To make current equal to 0, you open circuit. So the Z parameter is actually an open circuit test, whereas the Y parameter or the admittance parameter is the short circuit test, because you want to make the voltage part equals to 0 when you want to solve for the parameters values. Okay, the hybrid parameters, you relate the voltage equation and current, but you refer you have the general equation for the hybrid parameter, an equation of V1 and I2. Okay, so that in the equation you will have V1 and I2 is equals to the H parameter multiplied by the other current and voltage equation. So each parameter always have two sets of variables, I1 and V1 at the input, and at the output side we always have I2 and V2. Okay, so each time you want to solve for any parameter, you just manipulate the four variables. Okay, so when you have the hybrid parameter is equation of V1 and I2, the inverse of the hybrid parameter, you want to evaluate I1 and V2. Okay, so that in the inverse hybrid, I1 V2 is equals to G times V1 and I2. And the last set, the transmission parameter, you want to evaluate the voltage and current, V1 and I1. So if you compare transmission and hybrid, hybrid is, the first equation is V1, the second equation is I2. Whereas transmission parameter, you are evaluating from the input side. You want to know V1 and also I1. In terms of the hybrid and the V2 and I2. So in hybrid equation, sorry, in transmission equation, you will have negative I2. Okay. And in the inverse, because in the ABCD parameter, you have V1 and I1, the inverse transmission should have V2 and I2. But still has a negative I1 in the right side of the equation. So if you recall this, you can derive your own equation because the parameters is taken from the equations. Okay, so generally you must be able to differentiate the differences between each of the parameters. Okay, in other words, let me put a video slide show. Hold on. Okay. So the this 1 hour lecture is simply we want to summarize and also do the cascade system at the end. Okay. So here we have Z parameter, voltage equation, Y parameter is current equation, hybrid is the first equation is V1, the second equation is I2, the inverse is the inverse of it lah, the first equation being I1, the second equation is V2. Whereas in transmission parameter, we have V1 and I1 equation, and the T parameter, which is the inverse transmission parameter, we have equation of V2 and I2. Okay, because we have all parameters, one system can be represented as any of the parameters. Actually, we can convert the parameters. In fact, assignment questions, most of you have attempted this inverse, this conversion parameter. So actually, we can relate each of the parameters. You can convert from one form of parameter to another form, but simply by using formula. So if you look at what equation is this? V1, V2. Straight away, you should be able to tell this is actually the Z parameter lah, because we have equation V1 and V2. And in terms of metric equation, V1, V2 is Z times I1, I2. So if you have I1, I2 equals to the inverse of Z times V1, V2. And this I1, I2, Z inverse is actually the Y parameter. Okay, and that means this part Z inverse is Y. So Y is actually the inverse of Z. So in matrix, it is easy to calculate for the inverse as long as you know the formula to find inverse matrix. So and the inverse matrix is simply when you have a matrix Z11, Z12, Z21, Z22, Y itself is actually 1 over determinant of the adjoint of the matrix. Remember, you have this adjoint. When you interchange the element of a 2 by 2 matrix, you can calculate the adjoint. But simply using calculator, there is a function in your scientific calculator. You just enter the matrix function. You enter element 1, 1, element 1, 2, 2, 1, and 2, 2. You just enter the adjoint, and then you calculate the inverse of that matrix. You don't have to actually calculate. This is only for manual calculation. But using your scientific calculator, you can obtain the value of this matrix itself without knowing the determinant. Delta Z is the determinant. But for the sake of calculating conversion, you still have to obtain the adjoint. Okay, where the adjoint, the determinant delta Z is simply the difference between the product of Z11 multiplied by Z22 minus Z21 times Z12. You multiply the first and the fourth entry minus the diagonal. So it's always cross over. So that is the determinant. Okay, so this is convert from impedance to admittance parameter. Okay, we can summarize because they always pair. Impedance is pair with admittance, hybrid pair with inverse hybrid, transmission is inverse or transmission or the ABCD parameter in pair with the inverse transmission parameter. So you can simply produce a table. Okay, determinant of Z is in mathematical form. You just put a straight line for the matrix. Determinant Y, you can obtain for any matrix the determinant value for each of the matrix. So you will have a determinant Z, determinant Y, determinant H. H represent the hybrid, and determinant T, which is the determinant of transmission parameters, ABCD parameter. Okay, and if you put equation 6 values here, the Z parameter, the Y parameter, hybrid parameter, G parameter, T capital, which is the ABCD parameter, and the T small t parameter, which is the inverse transmission. So you can put here on the vertical and horizontal, and you will relate. So that you can simply have the value, each of it. This table is, I don't like this table. There's another table. I think this one is from the textbook, but I like the other table. This table is a lot easier because, for example, you are given a value of transmission parameter or the ABCD parameter. You want to convert it into the impedance, you look at this value. So given ABCD, you can obtain the impedance parameter, where the impedance parameter by having the values of ABCD is simply determinants the matrix is this equation, only the Z11 over Z21 for the first entry in the impedance value, and so on. Okay, if you are given the impedance parameter, the equation to convert to admittance is this matrix. If you want to convert it into determinant, into transmission parameter, you use this equation, A over C divided A divided by C, and then the delta T over C, 1 over C, D over C for each of the ABCD parameter. You can also convert into the hybrid parameter. So that with this table, you can simply interchange from one parameter to another parameter. Okay, and let's do an example. Okay, this example, you are given an ABCD parameter with a value of 320, 1, 7. Question asks you to obtain the other transmission parameters. So we want to calculate for impedance parameter, admittance parameter, hybrid parameters, and the inverse, hybrid and inverse T also. So let's find the determinant first. The determinant of delta this transmission parameter, which is represented as the delta T, is simply crossover, multiply 3 times 7 A times D minus B times C. So that we will have 3 times 7 minus 20 times 1, and you will obtain 21 minus 20, which is 1. So your delta T is 1. Then the inverse transmission parameter from the table, from this table, T parameters. Oh, dalam table ni tak ada pula. The other table yang ada. But inverse T jarang guna. So the inverse T here, from the T parameter, this is the value. D over delta T, C over delta T, B over delta T. And delta T, the determinant of T is 1 value for the example. So that we will have, so D over delta T and so on. So D is 7, 7 over 1, B is 20, 20 over 1, you get 20. And then C is 1, 1 over 1, you get 1. And A is 3, 3 over 1 is 3. And the units for the transmission must be, you have to be clear lah. The first and the second is unitless, that they are unitless. This second entry is unit of ohms, and T21 is Siemens unit. Okay, that is the inverse transmission parameter. For the impedance parameter, okay, for the impedance, if you look at the table here, you see, you have this ABCD value. The inverse for the impedance parameter is Z11. This one is T, and then you will have Okay, delta A over C, delta T over C, 1 over C, D over C. So you plug in the value. A is 3, 3 over C, C is 1, 3 over 1 is 3. Delta T is 1, 1 over 1 is 1. 1 over C is 1 over 1, which is 1. And D is 7, 7 over 1 is 7. So you will have impedance having unit of ohms, or all entries are in units of ohms. So you will have the impedance values as 3117. The Y parameter, okay, same thing, you need to use the table, and we have Y, the admittance parameter. First entry is D over B, second entry negative delta T over B, and Y21 is negative 1 over B, Y22 is A over B. So you plug in the value. D is 7, 7 divided by B, B is 20, 7 divided by 20. And negative delta T over B is, which is negative 1 divided by 20 is 20, B is 20. So you got negative 1 over 20. And negative 1 over 20. A is 3, 3 over 20. So these are the values for the admittance. And the admittance has all entries have the units of Siemens, because it is the inverse of the ohms, which is Siemens unit. Okay, the hybrid from the table also, you will obtain H is equals to B over D, the first entry of the hybrid parameter. Second entry, H12 is delta T over D, and H21 is negative 1 over D, H22 is C over D. And if you plug in the value, B is 20 over D, 20 over 70. Delta T is 1 over 7. Okay. And if you notice, for each parameter, the conversion, like for example, the impedance is actually 1 over C times the entry. For the admittance, 1 over B. Okay, and for the hybrid is 1 over D times the determinant, so that you can have your own ease of method lah. If you are familiar with it, you can, but if you don't want to draw your own conclusion, you can simply take the equation formula from the table there. And here you will have the hybrid parameter is 20 over 7 and 1 over 7, and then negative 1 over D, which is negative 1 over 20. 7, D is 7. And the last one, C over D, 1 over 7. And the unit for the hybrid is ohms in the first entry, Siemens in the last entry. The other one is just the gain equation, transfer equation. Okay, and the last one, the inverse hybrid, which is the G parameters. You will have C over A, negative delta T over A, 1 over A, and B over A. So now, from one parameter, you can have 5 other parameters calculated from that same parameter. So regardless of which parameter you use, if you evaluate current or voltage in the circuit, they will produce the same answer. Okay, and okay, the G parameter, you will have 1 over 3, negative 1 over 3, and 1/3 and 20/3. And the units for the small g parameters compared to the hybrid, the units opposite lah. Here you have cement. The last one you have ohms unit. Okay. Okay. Now we move on to interconnection of networks. Sometimes you have cascade system. So interconnection means a big circuit can be composed of many sub-circuits. Okay. Often it is worthwhile to break up a complex network into smaller parts. The sub-network may be modeled as interconnected two-port networks. From this perspective, two-port networks can be seen as building blocks for constructing a more complex network. Okay. These connections may be in series, parallel, or cascade. Okay, so let's evaluate the difference. For series connection, consider the series connected network shown here. You will have network A, network B. Okay, and network B is at the bottom. It looks like parallel, right? But actually this is not parallel because the characteristics of series output from the first network enter the second network. So here you see I1 of I1 from I1 for the second network, which is we call it, you will see here an A and B. So if you have the big picture, I1 and here I2. So that in the input side you have V1 and V2, outer circuit. But internally you have sub network of an A and B. So the input to the internal network A, I1A. But the output of network A is I1 that enters to the network B. So you have I2 of A goes is to the I1 of B. And from the network B, the output of network B, I2 B is actually the output of the network lah. Okay, so here you will see if you carefully examine it, this network is actually a series network because the characteristic of series two-port network, the output from the first network goes to the second network. For parallel connection, the network must have a current that split into two sub-network. That is parallel system. But in this case, it goes one side to the next side. So you can have multiple sub-networks. You can have an A, and B, and C, and D, depending on how many sub-networks you have lah. Okay. Alright. So obviously here, then you have V1 with the internal networks, and if you measure, V2 is actually a total of the effect of the series connection of the sub-networks within this big network. Okay. They are considered to be in series because their input currents are the same and their voltages are added. Okay, so that you will have another characteristic is that V2 is V2, the output is added voltage of the two. Okay, the Z parameter for the whole network will be Z is actually equivalent to ZA plus ZB. Okay, so for a series network, it is like a series resistor lah. Because when you have a series resistor, R total is R1 plus R2. Similarly, for impedance network, you can consider total impedance of the network is simply impedance A plus impedance B if you have two series impedance parameters. If you have like 3, 4, 5 parameters impedance, you can add up together to produce the total impedance parameter. So that simplify the system. Okay. Example. Okay. In this example, you are given two network. The first network, you are given the parameters. The second network, you have the resistor. So you have to obtain the second network parameter. Okay. And you are given the V-in, Vs is as the V-in or the V1. And the output is measured across this 20 ohm resistor. So you have here I1, I2. Question asks you to evaluate V2 over V1. So in this example problem, you want to solve application problem where you need to find the impedance parameter first. Then from the impedance parameter, you can evaluate V2 and V1. V2 and V1, V2 over V1 means the ratio of voltage output to the input, which is actually the gain value, total gain of the network. Okay, so let's solve for this one. Okay, you can simplify the system into a two-port series system. You name the top part of the circle as network A, the bottom part as network B. Okay, so you have network B consisting of these 10 ohms and the impedance or the resistance from the top part lah. It's like T network on the top. Okay, this is obviously you can see because the current voltage here is total up and the current will flow into the next network. Okay, for T networks, we remember the bottom here NB can be represented as T network. So you have Z12B is equals to Z21B, and that is the value of the 10 ohm resistor. And Z11B is equals to Z22B, which is also 10. Okay. Okay, for series network, Z is equals to ZA plus ZB. So you have two matrix, matrix NA and matrix NB. Okay, so therefore, because all entries in the network B is 10, so you can total up the two networks, the two sub-network parameter, Z parameter values. So you will have ZA and ZB. That gives you 12 plus 10 is 22, 8 plus 10 is 18, 8 plus 10, 18 juga, and 20 plus 10 is 30. So the overall Z parameter for this system is 22, 18, 18, and 30. So from that, you can write the equation V1 and V2. V1 is 22I1 plus 18I2. V2 is equals to 18I1 plus 30I2. Okay, generally. But you have here 5 ohms and the side where you measure the voltage output, which we can sometimes we call it RL, at the load. You measure output at the load. So 20 means the RL. From this, V1 is equals to Vs minus 5I1. Considering NA and NB as only one black box. So you have Vs, which is the source here, minus 5 times I1. Okay, and V2 and on the other side is equals to the resistance across it, which is 20 ohms, I2. And because I2 is opposite to I1, so you have a negative 20, negative sign in front of I2. So here you have two equations. From here you can have I2 is actually negative V2 over 20. And from here you can plug into 18, substitute this equation into the general Z parameter equation. V2 is equal to 18 I1 minus 30 over 20 V2, because you have 30 I2 where I2 is actually 20 V2 over 20. So from here you will obtain I1 is equals to 2.5 over 18 V2, and Vs is equals to negative 5 I1. You expand it, which is equals to 22 I1 plus 18 times V2 over negative V2 over 20. So that you will have Vs is actually 27 I1 minus 0.9 V2. Okay, Vs is actually equals to 27 and I1 is this equation 2.5 over 18 V2. So you plug in into the equation. Vs is equal to 27 times 2.5 over 18 V2 minus 0.9 V2. And the question asks, now you have V2. So you can group V2 together. You will have Vs is equal to 2.85 V2. Okay. And then the equation only has two unknown Vs and V2. So therefore, V2 over Vs is simply 1 over 2.85, which is equals to 0.3509. So this is the gain for the equation. Okay, so by having this, you don't have to evaluate the internal, you don't have to know the details. You can simply use the impedance parameter in order for you to solve for the network itself. Okay, that is series. Now we go to the parallel connection. Okay, two-port networks are in parallel when their port voltage are equal and the port currents of the larger network are the sums of the individual port currents. So in this example, we have NA and NB. Current I1 will split into sub-networks, but the voltage will add up. Sorry, voltage from the first network shared to the next network. Okay, here you will see I1 enter NA, and at the same time I1 also enter network B. Okay, and here you will see V1 is actually connected to the this point, and the output I2 and B2. So as long as you see the keywords is look at the current. So if the current is from the first network to the next, that means it is series. But if the current is shared parallel, that indicates a parallel network, parallel two-port. Okay. Here the Y parameters of the entire networks are, so when for a parallel network, the admittance Y is equals to the admittance of the first total admittance for the whole network is actually summation of individual impedance admittance parameter values. Okay. An example. Okay, if you see here at the input side, it splits into top and bottom. So that clearly shows the parallel network. Question asks you to find the Y parameter. So let's consider the top section as network A and the bottom section as network B. Okay, so this one shows the parallel network. And for parallel, best representation is admittance parameter. Although you have many network parameters that you can represent, you would choose the best representation lah, easy representation. So for series, you represent it as impedance parameters. Parallel connection of two-port system, you best represent as admittance parameter. So now we solve for the Y parameter lah. And for Y parameter, we have a pi network. Okay, and Y12A is equals to Y21A, and this one is J negative J4. Y11A equals to Y11A is equals to this 2 plus J4. Y22A is 3 plus J4. So therefore, YA is equals to 2 plus J4 minus J4 and minus J4, 3 plus J4. And the Y12 and Y21 is always the same value. Okay, negative, why being negative? Because a capacitor is always 1 over J omega. So if you do not like J in the bottom, you bring up, you multiply by J over J, you will produce negative J. Okay. A capacitor always gives a negative J. For inductance, you have inductance is close to the resistance value. Okay. Then your Y for the second network, Y12 equals to Y21B, which is negative 4. Because this is a resistor, so you don't have the complex number J. So it is a constant number 4 from the resistor value. Y11B is equals to 4 minus J2 and Y22B is 4 minus J6, this one. Okay, so therefore, the overall YB, second network, second sub-network here, you will have YB is 4 minus J2, minus 4, minus 4, 4 minus J6. And the unit for the admittance is S, Siemens. So now you have YA, you can obtain the overall admittance for this network. Y, total Y is equals to YA plus YB. So you just add together. 2 plus 4, 6. Okay. 6 plus J2. And the second entry, negative J4, negative 4. And the fourth entry, 3 plus J4, you get 7 minus J2. Okay, so that's about the total admittance network for a system. Okay, now a cascade. A cascade series of networks at first glance appears to be series connected system. But note that here, the output of one network is directly sent into the input of another network. So you can see here, B1 and A and B. So this is considered a cascade. It's not series connection. And here you will have I2 enter, but I2 at the same time becomes B. And voltage V2 is actually voltage into the second network. So in other words, cascade is overlapping of series and parallel. Kalau series saja, the first network current enter the second network, but the voltage is added together. But for parallel network, the voltage is from the first one enter the second network. The current split. But for cascade system, current and voltage from the first network enter the second network. So it's actually cascade system is a representation of overlapping of series and parallel network. Okay. For a cascade network, the best parameter to represent is the transmission network. Where for a cascade system, you have total T network parameters there is actually multiplication of the first transmission parameter multiplied by the second one. So that transmission network is actually produce a bigger transmission parameters because T is equals to TA times TB. So you understand that the output of a cascade system requires considering the flow of a signal through the system. A signal enters the first two-port network and is changed by the transmission characteristics. And this altered signal then enters the next two-port network and is again altered by its transmission parameters. So the overall transmission is actually multiplication of the internal transmission parameters. Okay, an example. You are given a network of many resistors like this. You have 4 ohms, 1 ohms, 8 ohms, 2 ohms, and then 6 ohm. Find the transmission parameter by evaluating cascade ataupun series ataupun parallel by representing the system as individual parts. You break into smaller component, then you evaluate the overall. Okay, so you consider here, if you look carefully, this should be a cascade network where you can break, put a line here. The left side is an A, the right side considered as NB. So that you will have the first one, and our overall will be R1. R1 is represented by this first T. So you need to find this R1. The first network, 4, 8, and 1 will give R1. Plus this R3, R2. But this 4 is actually also a T network. Okay. So if you solve for this one, transmission parameters there, you have A, B, C, D parameters, right? So here you have A is actually 1 plus R1 over R2, and B is R3 plus R1, R2 plus R3 over R2. C is 1 over R2, and D is equals to 1 plus R3 over R2. So if you plug in the value, A, the first network, is equals to 1 plus 5, which is 5. B of A is equals to 8 plus 4 times 9. Thirty-six plus 8, you get 44. C of A, which is 1 over R2, 1 over 1 lah, dapat 1. D is 1 plus 8 over 1. 1 plus 9, 1 plus 8 becomes 9. So now you have T transmission network, transmission parameter for the first network A, 5, 44, 1, and 9. The second network B and B, AB is equals to, here you have, you can convert this 1 R1 over R2, where R1 is 6 over 6. So this value, if you sum up together, you will get a value of 6. 1 plus 6. You get. And B of B, which is R3. R3 is 6. And R1, R2, R1 times R2 plus R3 divided by R2. Is 6. Okay, B is actually this value lah. And CB is 0.5. And DB is 1 plus R3 over 2, 6 divided by 2. So that the TB, the transmission of the network B, is 1, 6, 0.5, and 4. And the overall transmission parameter for this circuit is TA times TB. And TA times TB is, you multiply, when you multiply a matrix, first entry times the second entry of the second matrix, first times first, plus 44 times 0.5. But using your calculator, you can just enter matrix A, matrix B, enter answer, you will get overall lah. The second one, 5 times 6 plus 44 times 0. 44 times 4. And the second row, 1 times 1 plus 9 times 0.5. And the fourth entry, 1 times 6 plus 9 times 4. So altogether you will get 27, 206, 5.5, and 42. Okay. This is how you do it in terms of cassette. But some student maybe wants to convert into delta network, summarize, and then after that you can convert into, that's another way juga. But the final answer would be the same. But because we are in the, it depends on the question. If the question asks you to do transmission networks, clearly state to solve for the circuit using certain method, you have to follow the instructions from the questions. Okay, so in this case, we have this transmission parameter. Clearly, if it is a cascade system, you evaluate the transmission. If it is a series, you evaluate in terms of its impedance. If it is parallel, you evaluate in terms of its admittance. So that's all for this chapter. Okay, regarding assignment, the date I have checked yesterday before class around 9 o'clock this morning. When I tried to click the student view, now the due date is seen as 15 June. So if in case you all masih lagi nampak 8 hari bulan hari ni, so please alert me so I maybe can find that. But from my view this morning, everybody sees it as 15 of June as the due date. Betul tak? Anyone sees the assignment due masih lagi 8? Saya tersilap.
Masih lagi 8 doktor.
Masih lagi 8?
Doktor,
Dalam
masih
saya punya
8.
8 lagi ya.
Masih 8.
Tapi when I enter another lecturer's date, and Dr. Badaria, I use her account, she sees as 15. Kenapa ya? But the due date is not today lah. I made a mistake. I wanted to make Tuesday the following week, but I mistakenly click 8 hari bulan. But the due date is meant for 15.
8.
Ada yang nampak 15 tak? Tak nampak eh? Nanti saya cuba lagi tukar. And then there's one question from this assignment. I think question number 9 tu. Question number 9. Let me see. Let me see if I have. I stop recording. I stop sharing. See from my I want to share. Okay. So if you see, this is my view. My view definitely it's 15 of June. Okay, hold on. I go back. If I click student view, from student view here, assignment 7. You can see here, the due date is June 15. This one. Tak tahu kenapa you all punya view nampak 8. It's okay, you just submit. It shouldn't be penalized lah if you submit later than today. And then one of the question, so I return to my view. One of the question here, question number 9. Question number 9. Maybe I should go straight. This question, where you are to calculate the hybrid parameter. Given this circuit, find the H parameter. Few students have alert me, I think at least 3 students. And I've checked the working. working all correct. Cuma the answer is connect C as wrong answer. So for this question, I haven't report the issue. I will give bonus mark for this question. So you just submit, you just do for this, solve for the problem. You can enter, even you get a wrong answer, you will get a full mark for this answer because it will take some time for connect people from the McGraw-Hill to reflect correct answers into their system. So as for now, this question is a bonus question for you all because the mistake is not from our side. The mistake is McGraw-Hill itself. Their database do not have a correct answer in their system. So this one is considered a bonus question for you all. So that at least good that you can solve this problem. Okay, and then lastly, my slide finished already. And where is it? I stop sharing this one. I go back to my slide tadi. Okay, the last part is submission of due date. I extend because of there is circuit B tu saya silap copy paste circuit tu. So sepatutnya ada 3 elemen. So I extend instead of sepatutnya due date dia berapa? 8 hari bulan. Sepatutnya due date tu 8 hari bulan. So saya extend sehingga hari Jumaat. My announcement said I want to extend to group students who are doing group B, circuit B saja. Tapi sangat susah untuk saya cari and then cari student group B and then buat manually one by one. Very difficult. So I just extend for everybody. As of this morning ada 10 students, 10 group dah submit. Tahniah, you all fast group yang solve the problems early. So thank you for those. Also I will expect another 52 groups. Ada 66 group. So ada 56 more groups to hand in. Alright, so I think that's all for today. And you can always contact me if you have any issues. Just text me in Teams. I will try my best to attend to you all. And so that's it lah. So any questions? Any specific questions? Before we call off for the class?
No, Doctor.
Stop recording. Okay. Is it still continue? Stop recording.